Hello everyone and welcome to today's presentation on congestion and flow control in data communication and networks. And then when talking of congestion and flow control, these are essential concepts in data communication and networks that ensure efficient and reliable data transfer. So what is congestion in data networks, right? Congestion occurs when the amount of data being transmitted over a network exceeds the network's capacity to handle it. So this can lead to delays, the packet losses, and decreased network performance. Right? So imagine a highway with a maximum capacity of 100 cars per hour. If 150 cars try to use the highway at the same time, congestion occurs, leading to traffic jams and delays. And similar in a network, if too many devices try to transmit data at the same time, congestion occurs, right? Then we are talking of congestion control. We are talking of the techniques and the mechanisms used to prevent or mitigate congestion in a network. So congestion control ensures that the network operates efficiently and reliably even under heavy loads. I can give an example of a university network. It's a limited bandwidth of 100 megabits per second. During peak hour, 500 students try to access the internet simultaneously, causing congestion. So to control congestion, the network administrator of a university can implement a congestion control algorithm that limits the bandwidth allocated to each student, ensuring that everyone gets a fair share of the available bandwidth. So now talking of a flow control, a flow, this one refers to the sequence of packets transmitted from a source device to a destination device over a network. So flow control now refers to the mechanisms used to regulate the flow of packets between devices. So flow control ensures that the sender does not overwhelm the receiver with too much data, which can lead to congestion and packet loss. Flow control mechanisms regulate the amount of data that can be sent at one time, right? So imagine a sender device trying to send a large file to a receiver device over a network. Without flow control, the sender might send too much data at once, overwhelming the receiver and causing congestion. So with the flow control, the sender sends packets in a controlled manner, waiting for acknowledgements from the receiver before sending more packets. We need to explain the causes of congestion. One, we're talking of a high traffic volume. When too many devices are transmitting data over the network, it can lead to congestion, right? Then sudden spikes in data transmission. This is what we call high traffic volume. Then we talk of network limitation. Network limitation such as limited bandwidth or processing power can contribute to congestion, which is insufficient bandwidth or hardware capabilities. We are talking of inefficient routing, and we are talking of inefficient routing. We are saying that inefficient routing algorithms can lead to congestion by routing too many traffic over a single path, and also purely configured network path can lead to bottlenecks. Then we also need to explain the effects of congestion, right? There is increased latency. Congestion can lead to increased latency as packets take longer to reach their destination. So delays in data transmission can occur, affecting real-time applications like VoIP and video conference. Then we're talking of packet loss as an effect of congestion, and congestion can lead to packet loss as packets may be discarded by intermediate devices. So excessive data can overwhelm buffers, leading to dropped packets and the need for retransmission. We can talk of throughput reduction as an effect of congestion. You are talking that congestion can lead to reduced throughput as the network becomes saturated with traffic. So overall data transfer rates decrease, impacting download and upload speed. Then there is a degraded quality of service, with the QoS. And this one can lead to degraded quality of service, as applications may not receive the necessary bandwidth or priority. So applications may experience interruptions, leading to poor user. Then we also need to talk about congestion and flow control. This one in data networks. So in a data frame, a layer 2 data is sent from one host to another over a single media. It is required that the sender and receiver should work at the same speed. That is, the sender sends at a speed at which the receiver can process and accept the data. So flow control ensures that the sender does not overwhelm the receiver. It is a set of procedures that tells the sender how much data it can transmit before the data overwhelms the receiver. So the receiving device has limited speed and limited memory to store the data. Therefore, the receiving device must be able to inform the sending device to stop the transmission temporarily before the limits are reached. So it requires a buffer, a block of memory for storing the information until they are right. So the stop and wait mechanism is a simple flow control mechanism and ensures reliable data transfer. This is how it works. One, the sender sends a packet to the receiver, right? Then the receiver receives the packet and sends an acknowledgement, right, to the sender. The sender receives the acknowledgement and sends the next packet. If the receiver does not receive a packet, it sends a negative acknowledgement to the sender. The sender receives the negative acknowledgement and retransmit the package. This is how the stop and wait work. Then we also want to explain the sliding window. And we're talking of the sliding window, we're saying that the sender sends multiple packets and maintains a window of packets that have not been acknowledged, right? So multiple frames can be sent one after another, due to which capacity of the communication can be utilized efficiently. A single acknowledgement acknowledges multiple frames. So sliding window refers to the imaginary boxes of both the send and the receiver end. So the window can hold the frames at either end, and it provides the upper limit on the number of frames that can be transmitted before the acknowledgement. This is how it works, right? The sender sends multiple packets to the receiver one. The receiver receives the packets and send an acknowledgement, right? The sender maintains a window of packets that have not been acknowledged. When the receiver sends an acknowledgement, the sender slides the window forward and sends new packets, right? This is how our sliding window works. So frames can be acknowledged even when the window is not filled, right? And the size of the window is represented as n-1. Therefore, a maximum of n-1 frames can be sent before the acknowledgement. When the receiver sends the acknowledgement, it includes the number of the next frame that it wants to receive. For example, to acknowledge the string of frames ending with the frame number 4, the receiver will send the acknowledgement containing the number 5. When the sender sees the acknowledgement within the number 5, it gets to know that the frames from 0 to 4, through 4 have been received, right? So those with questions, you are free to write in the comment section. You are free to comment, like and share this video. End of our today's presentation. Thank you for listening.